Hello from Dendrite Digital in Anaheim, makers of the Virtue Data Processor, and ZipBits, the website made entirely of human-readable JavaScript, HTML, and CSS. So here we are in the Vivado first screen, and we got a number of things that we can select here. We got Create Project, Open Project, Open Example Project, Manage IP, Open Hardware Manager, Vivado Store, and down here we have Documentation and Tutorials, Quick Take Videos, and What's New in 2021.2. So here it is, 2022, and they have a new version out, but I haven't installed it yet. Don't know if I will. I kind of like what this does from the beginning. No need to upgrade just yet. So what we're going to do is create a project. Come up here to Create Project and click on that. And so now it's asking if we're doing a new project. We say yes to next. And we're going to put this in the project folder. Let's change the parent directory. And we're going to call this LED. And we're going to put it in the Vivado ML folder. I created that folder, by the way, and put all my files in there. And it's going to make a subdirectory. And we're going to specify the sources. So leave that checkbox unchecked. And here we're going to create a source file. We're going to name it LED .v. Okay. And we're only going to need one of those. So yeah, it's just a real simple project. We're going to get a LED flashing. That's all we want to do for this. Keep it simple. And we need the constraints file for our board. Whatever maker model that you're using, as long as it's Xilinx, a Xilinx FPGA, this is what you should do. I'm going to add a file. And we're going to get it from... what would be a good one? Get the... let's go into video. There it is. Nexus Video Master XDC. That's the constraints file. And click OK. And go next. And we need to select the right FPGA for this. I'm using a Nexus Video, and that has an Arctic 7 on it. And the Nexus Video has the big one, the T200T. It's on an FPGA 484, and there's the only one it'll do. So we have all those, and we click Finish. and let's define it. So we're going to have an input. We need it to be CLK for the system clock. It's an input. So then we go plus, and then we're going to do an output. Let's just go LED for now, and it's an output. And I think that's all we need. So click OK. And now we're going to go into the LED file. Let's look at the constraints file for a moment. It's likely got some commented out things in it. Maybe even the clock is commented out, because that's how these files are at the beginning. Everything's commented out and absolutely nothing connected. So this is specific to the Nexus video, this XDC. So we can see that the clock does not have a pound hashtag on it. So these are active. But if we come down a little ways, let's see if we, see this, we got two switches that need to be commented out. We'll come back to those, reactivate them later. And we need LED. Yeah, see, this is the P mod for a 12-bit display. VGA. And I think that might do it. And there's the FMC, the famous many connections FMC. And we'll leave those good. So back up. So we need to find LED. Need to find an LED display port, HDMI, in and out. There's the OLED display. That's not what I'm looking for. I just want an LED. There's the LEDs. LED 0. So let's uncomment this. And let's just call it LED. And we'll save it. And go back to Vivado. And up to the LED file. So let's just make sure we're on the same page. And we're gonna need a counter because 100 megahertz we won't see it flashing at all. So we need a reg as a counter. So the way I figured the 26 is we need half of a second. And if it's going to go 100 million cycles in a second, we need a half that number to toggle it on and off. So 20 is a million. That's for every 1024, there's 10 bits. So 1,000 times 1,000 is 20 bits, and then 50 is between 64 and 32, and round it up to 64 because we want the counter to go up to 50 million, not 32 million or below. So we need 26 bits. Actually, this should be a 5. We don't need all that many bits. We need 26 of them. Let's just call it CNT for count. And then here, we need to always use always. Always use always. I'm going to put it on a positive edge. And we're going to use clock. And then we have to say begin. And we'll go if CNT equals 50 million 50 1 2 3 thousand 1 2 3 million. Put if it's equal to this, CNT equals 1. And another thing we need to do is initialize count. We need to have all of our regs initialized. So we'll put that up here. Count equals 0. And we could make this non-blocking just so it happens at the right moment. And then here, and here we're also gonna actually the LED needs to be a reg. So we'll come in here, we'll make this a reg. And we need to initialize that too. And then here we're just going to toggle it. LED equals the opposite of LED, like that. And else, we need to fix this. Else, we're gonna make count equal count plus 1. So that ought to do it. Almost ought to do it. Just look over it a little bit. Now there's a step I'm leaving out here, And don't you do the same, because it's important. You need to do a unit under test. If it's anything more complicated than this, it needs to be tested to make sure everything's working right. And for instance, if I didn't initialize these, it wouldn't work at all. It would just do nothing, probably. But here I've initialized my regs, the LED and the count, and so it's going to count up to this with the add, and when it gets there, it's going to set it back to 1, and it's going to toggle the LED on and off. Okay. So then we go to Vivado, and we're going to close this, and we're going to scoot this up, and we're going to click on log, and we got it set to synthesis, and we're just going to do run synthesis, see if we have any problems with it. This is going to take a while. Nexus Video is a big, monstrous FPGA, and it's got to figure out what it does with the whole thing, apparently. This is going to take a while. So here it is. We've finished compiling. Let's just get a look at this real quick here. So yeah, it starts running, shows you the version it is, and loads the source, and tells you a bit of information about loading what part. We're doing this for synthesis. Multi-threading enabled for synthesis design using, yeah. And so it goes through all this nonsense. Tells you what you got. And all of this in here. And here's all the hardware that it's using on the chip. Not much to it. And exit. So now we want to implement it. I'm going to put it into an implementation. And again, if the file was any more complicated than this, you need to go and make a user a unit under test, and now we're going to implement it, and this will take a while. Yeah, sometimes this hinks up. It gets stuck, and it won't display anything. It won't even come out with that message right there. But if it drops down a row from here, I think that's already dropped down a row. You're usually pretty good. If it displays this and then it drops down a row, it'll probably display the whole thing as it's doing it. But sometimes nothing shows up in this window. And in that case, you come up to cancel and start it over. And sometimes it'll come back, and sometimes you can start it over a dozen times. It won't display this. And in that case, you can just let it run its course. You won't know if it's going to finish or not. and it just spins and spins and spins, and you'll never know. So it's going to come up with another message here, hopefully. Yep. And so we're good. It's probably going to display the whole thing. So here we are, maybe 10, 20 minutes later. Just for flashing an LED. That's what you got to do if you're using a Arctic 7 200T. Very overpowered for the application. So here we want to generate Bitstream. And while it's doing that, we can look here, and we've passed timing with flying colors, or actually black and white instead of red and white. If this shows up red, you haven't passed timing, and you got to go in and see what's doing the slowdown. In a later episode, I'll show you how to do that. But this 83% means it's doing the Bitstream. It'll show 100% here after you've done the implementation. It just bumps it back down to 83% when you're writing the Bitstream. I don't know. It's got some quirks. So here we are in implementation. So if we look at the time that it started, let's look at the time. Let's see where it started. So it started here at that's copyright. Where's the time it started? I want to see the time it started. Doesn't look like it's going to tell me. I think it tells you the elapsed time down at the bottom, how long it took, but it's not quick. I'm not seeing the time here. It tells you when it exits. It was about 5 o'clock when I started. So, 23 minutes. And here we're generating the Bitstream. If we go back to here, that's all it's going to tell us. So here we finished generating the Bitstream, and it's ready to be loaded onto the FPGA. So here we go. We're going to open Hardware Manager. Open Hardware Manager. The more complicated software gets, the longer it takes, and the more careful you have to be with it, because unexpected things can cause havoc with software. Certainly true of Vivado. you got to do everything with delays in between what you're doing. So the software has time to catch up to what you're up to. Otherwise, it hangs up and crashes and maybe it's my system. I just have a little dinky Atom processor. Got the computer for under $200. Just plug it into the TV. And here we go. Come on. And ready to program device. Let's see what we get. And we have a blinking LED. Hold on, I'll show you. Just give me a moment. So here we have a flashing LED, and it seems to flash on and off every second. 1, 2, 3, 4. That sounds like a second to me.